Okay, now this next part here, I'm going to do writing chemical equation and ionic equation. So those of you who are new to this, okay, so I'm going to just run through everything. I'm going to do both together. So for all the equations that I'm going to show you here, what I'm going to do is I'm going to convert from word equation to chemical equations. Okay, and definitely the chemical equation that I'm going to write will be balanced. Okay, balanced. Thereafter, I'm going to convert from chemical equation into ionic equations. Now, I'd like to highlight here that for chemical equations to ionic equations, one very important part is actually the state symbols. So I'd like to say that you must be familiar with the state symbols. So just a quick run through here. So what you're going to see are the following state symbols. Now, G stands for gaseous states. So this means that the compound, the substance, the element is actually a gas. L stands for liquid. So it means that the substance is a liquid. S is for solid. AQ stands for aqueous. Now, what is aqueous? Aqueous just means dissolved in water. Okay, this state aqueous here is actually extremely important for ionic equation, for ionic compounds. Okay, so we put a star here, ionic equation, star here, ionic compounds. Okay, so let's start off with examples. So I'm just gonna from word equation to chemical equation, and then from chemical equation to ionic equation. As a way to show you how to go about doing so. So the first one I'm going to start off with is this. So I'm going to have ammonium chloride. So ammonium chloride. Okay, ammonium chloride here is aqueous. Sodium hydroxide, aqueous also. What I'm going to get, okay, when ammonium chloride plus aqueous sodium hydroxide, what I'm going to get is actually sodium chloride, aqueous, plus water, which is liquid, plus ammonia gas. Now, so this is the word equation. Normally it's given to you either in a problem, in a paragraph, then you have to extract it, or if the question is good, okay, they are very nice to you, they just give you the word equation as such. So how do I go about doing the next step? So from word equation to chemical equation, first things first, okay, before I even go into balance. So word to chemical, this is the first step. From chemical to balance is the second step. Okay, and then once I got the balanced chemical equation, then I will move on to the ionic equation. Okay, so let's go on to the first one first. Let's form the chemical equation. So how do I go about doing this? This is where your chemical formulas have to be very strong. You have to be able to decipher what is the chemical formula for each of these substances. If you're unsure, you can refer to the YouTube playlist that I have on chemical formulas. So go back and revise on those. So first part, ammonium chloride is actually NH4Cl. Just bring down the states. Sodium chloride is NaOH. Sodium chloride is NaCl. Water is H2O. And ammonia is NH3. So this is the chemical equation that's not balanced yet. Okay, let's check whether everything is balanced. So I have to go and write my little squiggly lines over here, draw a line like this, show before and after. I got 1 nitrogen here, 4 hydrogens, 1 chlorine. I have 1 sodium, 1 oxygen, and 1 hydrogen over here. Okay, you realize I'm still keeping to the rows, so each element will have a row. Down here, 1 sodium, 1 chlorine. Down here, I have 2 hydrogens, 1 oxygen. Down here, I have 1 nitrogen, 3 hydrogens. first row, nitrogen, balanced. Next row, 4 plus 1, 5 on the left-hand side, 2 plus 3, 5 on the right-hand side, balanced. 1 chlorine, right, left, 1 chlorine on the right, balanced. 1 sodium on the left, 1 sodium on the right, balanced. 1 oxygen on the left, 1 oxygen on the right, balanced. So this is now a balanced chemical equation. So that's good. So we are done with the balanced chemical equation. So step 1 and 2 done. 1 plus 2 settled. So how do I go about getting this into the ionic equation? So this is where you need to split everything up. Okay, you can only split the ionic compounds in aqueous states up. So I say again, okay, to be able to do this, I do take note what I'm doing from the chemical equation to the ionic equation. I'm actually splitting the ionic compounds, okay, into the ions in the aqueous state. Okay, so for ionic compounds in the aqueous states, I'm going to split them up into the ions. So let's use a different color here. Okay, let's try this. It's too colorful for me, but never mind, let's just try it. Okay, so first one, ammonium chloride. Actually, what I have here, actually, do take note, there's actually a number 1 in front of all of this. So ammonium chloride, if I split them up, is actually NH4 plus aqueous. Okay, this is too colorful for me. We're going to just switch back to a standard color. My apologies. Okay, NH4 plus in the aqueous state, chloride in the aqueous state. So because ammonium chloride is actually formed by ammonium ion and the chloride ion, because their states is aqueous, that's why you're able to split them up. Same thing, sodium hydroxide is an ionic compound in the aqueous state. So I'm going to split it up into Na plus aqueous plus OH minus aqueous. Okay, so I've split up my ionic compounds in the aqueous state into their respective ions. On the right hand side, you realize, oh, sodium chloride also aqueous. Can I split them up? Yes. So I got Na plus aqueous over here, chloride, Cl minus aqueous over here. How about water? Can you see this in a liquid state? And it's so because it's in a liquid state, not the aqueous state, we don't split them up. So this is just H2O liquid. Ammonia gas, gaseous state. So we don't split them up also. So once I've done this, okay, we are almost done here. Okay, so to really be able to do the ionic equation, first thing you must know how to split it up. This is a very important step. And to be able to do this, you must be very familiar. So I need you to familiarize yourself with ions. Okay, with the possible ions in terms of the charge and what states they are in stuff like this. Okay, so now once we are done here, we will need to look at the next part. So the next part is we need to cancel. Okay, so what I'm doing here is to do this thing called the cancelling the spectator ions. So I'm doing what I'm going to do now in green color. Maybe let's not use green. Let's use rainbow color again. Okay, I'm going to cancel out the spectator ions. Now, what are the spectator ions? The spectator ions are those that are the same before the reaction and after the reaction. What do I mean? Look at sodium. Look at the sodium ion. Before it's an Na plus aqueous. After it's also still an Na plus aqueous. There's no change in the sodium ion. So because of this, in this whole equation here, they are just like spectators. They just look at the reaction, but they don't really get involved in it. So cancel this out. Chloride, you can see is another one. I'm going to cancel out. So once I cancelled out, let's just double check. Ammonium I have before, after no ammonium. Okay, can you see these two are different? This NH4 plus, this NH3. They're different things. OH minus aqueous, H2O liquid. So once I'm done cancelling the spectator ions, the last part here, I'm just going to write down whatever that's left. So NH4 plus equals plus OH minus equals, it's going to give me H2O liquid plus NH3 gas. So this here is number 3, the ionic equation. So you really must be very, 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 very familiar with the ions. Okay, if you're not familiar with the ions, you will face a lot of difficulty in doing the ionic equation. Okay, so this is for this part over here. I'm going to move on to the next part. Okay, I'm going to try another question to show you how to go about doing the next one. Okay, maybe not to show you, but to just run through a few more examples. Okay, so I'm going to do some little magic here. Okay, ta-da! Suddenly you see the word equation here. Little magic. Okay, all I do was just pause the video and then after that write the thing, then I resume the video just to save some time on the video. Okay, now this is the next equation we're going to look at. So once again, the first step is to get the balanced chemical equation. So I'm going to run it through it a little bit faster now. So for calcium carbonate, I'm going to get is CaCO3 solid. Have the line in front here, so you know you need to balance it after that. Hydrochloric acid, HCl equals calcium chloride, CaCl2. With carbon dioxide, CO2. So this is the chemical equation. Now let's double check if it's balanced. So 1 calcium over here, 1 carbon, 3 oxygen. 1 hydrogen over here, 1 chlorine. Draw a middle line over here. So 1 calcium, 2 chlorine. 2 hydrogens, 1 oxygen, 1 carbon, 2 oxygen. So calcium is balanced, carbon is balanced, oxygen is balanced. The only problem lies with hydrogen and chlorine. So 2 hydrogen on the right, only 1 over here. So we need to put a big number 2 in front of here. So I'll multiply hydrogen by 2, multiply chlorine by 2. Okay, so with this, what I'm going to get is 2 hydrogens on the left, 2 chlorines on the left. Are they now balanced? Yes, they are. So this is the balanced chemical equation. So we are done with the balancing of chemical equation and balancing it. Now, how about the next step? How can I get to the ionic equation? So once again, remember, when there's a blank over here, it means that this is 1, 1, 1. For ionic equation, what we're doing, we are splitting the ionic compounds that are in the aqueous state. So can I split CaCO3? Answer is no. So I'm going to use a different color now, green. So this is now the third step, the ionic equation. So calcium carbonate, I can't split it. So I'll just put here CaCO3, solid. Hydrogen chloride in the aqueous state. So actually I can split this up to hydrogen ions and chloride ions. So what I'm going to get is hydrogen ions in the aqueous state, chloride ions in the aqueous state. Now because I have 2 of this, so can you see here? So I will have 2 hydrogens, ion, 2 chloride ions. Now going to here, calcium chloride. So I will have 1 Ca2 plus ion equals calcium ion. Okay, oh, sorry, I will not write the 1 over there to prevent confusion. I shall not write it there. Then what I have is Cl2 here. The Cl2 means that there's 2 chloride ions. Common mistake people will write is, oh, I got Cl2 minus equals. If you write this, wrong. Okay, you must remember that the chloride ions is actually a Cl minus. Okay, then the 2 here just indicate there's 2 Cl minus. Next one, H2O liquid. Liquid I can split it up, so I'll just put H2OL liquid here. Carbon dioxide gas, so CO2 gaseous state. Now, once I've reached this step, the next part is really just to cancel out the spectator ions. So let's use my multicolor again. So the only one I can cancel out is the chloride ions. Once I cancel out the chloride ions, my final answer would be as follows. Okay, let me use my blue pen. Okay, blue pen. Let me scroll down. So after cancelling these two, what I'm going to have is actually CaCO3 solid plus 2H plus aqueous. This will give me my Ca2 plus aqueous plus H2O liquid plus CO2 gas. So this is the ionic equation for calcium carbonate plus hydrochloric acid, giving calcium chloride plus water plus carbon dioxide. Okay, so this one over here is my next equation. So let's go on to something else. Okay, let's try another one. Last one I'm going to do. Okay, this one will be an interesting one. Okay, so I'm going to do a little magic now again. Okay, now, so this is our last equation I'm going to do is potassium hydroxide aqueous plus nitric acid aqueous, giving me potassium nitrate aqueous plus water liquid. So first thing, let's do the first most important one. Let's get the balanced chemical equation. So get the chemical equation and balancing it. So potassium hydroxide is KOH aqueous. Have a blank space in front just to make sure that you are able to balance it. Nitric acid. Okay, what I'm going to get is, okay, maybe let me change the equation a little bit. I don't like this nitric acid over here. I want to change it. Okay, let's make this a little bit more complex, a little bit more difficult. Since anyway, it's going to be the last example I'm going to do in this video. Instead of nitric acid, I want to change it. Okay, now let's go back. I get is so this is my chemical equation. Let's balance it. I got one potassium here, one oxygen here, one hydrogen here. Two hydrogen. Now I have one sulfur. For the line, two potassium here, one sulfur. Here, I got two hydrogens over here, one. So let's start off with the one potassium. So what I need to do is multiply the potassium hydroxide by 2. So 2 times of this whole thing here. So 2 potassium, 2 oxygen, 2 hydrogens. So first row potassium balanced. How about oxygen? 2 oxygen here, 4 oxygen here, so I got 6. Here I got 4. So what can I do on the right hand side? Multiply by 2. So I also need to multiply the hydrogens here. So I will have 4 hydrogens over here. So now let's look at the next row. 2 plus 2 hydrogens on the left hand side. So that's 4. Right hand side, 4 hydrogens balanced. One sulfur here, another sulfur here. So that's balanced. So this is my balanced chemical equation. Okay, so this is good. So my balanced chemical equation is done. Now let's go on to the last part, which is the ionic equation. So number 3, ionic equation. Try to split them into their respective ions. So KOH is actually made out of K plus equals and OH minus equals. So if I have 2 of them, so I got 2 K plus, 2 OH minus. H2SO4 is actually made up of hydrogen ions, aqueous state, plus sulfate ions. Okay, sorry, sulfate ions is 2 minus, aqueous state over here. So how many of them do I have? Can I see this H2? So I got 2H plus, 1 SO4, 2 minus. Okay, so these are all the ions on the left hand side. On the right hand side, I got K2SO4 equal state. So this is actually made of K plus, two of them, in the aqueous state, plus SO4, 2 minus in the aqueous state. Next one, I have H2O liquid. So 2 H2O liquid. Now, why didn't I split this? Once again, you normally only split those in the aqueous state. So liquid state, no splitting. Okay, so with this here, now it's time to cancel these spectator ions with my colorful pen. K plus aqueous, K plus aqueous. So let's strike this out. SO4 2 minus equals state, so out. So what I'm left here is this. So my ionic equation is actually 2OH minus aqueous plus 2H plus aqueous, giving me 2H2O. Now, what you can see here is not done yet. Because can you see 2 is to 2 is to 2. So what I can do, I'm going to simplify it. So my final ionic equation is actually OH minus aqueous plus H plus aqueous, giving me H2O liquid. Okay, you're going to learn about this a little bit later on, but this is also known as the neutralization ionic equation. Okay, now, I guess some of you would be struggling at this point when you're doing the ionic equation because of this. Okay, so I'm going to just use a colorful pen to just highlight some of the things that most probably you will get wrong as you're doing ionic equation that you must be a little bit more aware of. So converting from this H2 to 2 times H plus, K2 to 2 times K plus, okay? Converting this whole thing here into this. Now, why would people have problems with this is because of the familiarity, okay? Familiarity. So once again, back to basic, you must be very familiar in the ions that will be formed for each of the elements, or even be very familiar with the complex ions. So if you're not familiar with it, you realize you'll run into a lot of issues, a lot of troubles, and you will need to definitely you will definitely face some confusion along the way. So just take note, familiarity with ions is a big star. So if you're not familiar with it, you might want to do more of the chemical formulas formation, okay, or even referring back to your textbook, looking at the ions present, okay, the state of each of the ions of the various elements. So this is it for chemical equation and ion equation. So that's all. So and practice, so that you are very, very familiar with this.